This research was carried out in order to create new information on the properties of viscosity and bring them to the new realm of acrylic paint. This issue is relevant because it will bring helpful insights to painters as well as expand upon the set principle of viscosity that an increase in temperature leads to a decrease in viscosity. Graham has found that the principle does not apply to motor oil, and after a while, the viscosity in motor oil increases while the temperature increases as well. The question I want to answer is if acrylic paint is tested at temperatures of 5, 20, 40, and 50 degrees Celsius, then higher temperature trials will have lower viscosities. The samples were made using a graduated cylinder, acrylic paint, a marble, a ruler, a thermometer, a microwave, a freezer, and a stopwatch. The equipment was set up by filling a graduated cylinder up to the brim with acrylic paint that was manipulated to the desired temperature. From there, a marble was placed in the liquid, and the time it took for it to reach the bottom was recorded. The recorded time was found by placing a camera underneath a graduated cylinder and recording until the marble reached the bottom. That time was converted into velocity using distance over time and into viscosity using Stokes' formula, where 2 times the difference in density between the marble and paint times the gravitational force times the radius of the marble squared all over 9 times velocity. I found that apple barrel paint does follow the known principles of viscosity and that higher temperature trials produce lower viscosities. I also found green acrylic paint had higher viscosities at each temperature trial when compared to red paint. This can be explained since when a liquid heats up, the molecules become less tightly bound, making the fluid have a higher flow rate and a lower viscosity.